Thank you so much for having me. Thanks everybody for coming. My name is Jake, originally from Ghana, and today we're presenting our first locally designed PocketQube, which is called 𝗖𝗁. For those of you who don't know where Ghana is in West Africa. It's a small country with over 25 million people, who is currently growing and getting bigger in terms of space and advanced solutions. So 𝗖𝗁 is a startup company that's based in Ghana. So our main goal is to develop small satellites, 25 by 25 by 25 millimeters, that will be very powerful and can also provide many solutions within Ghana and across the continent of Africa. So today I'll go through you guys with our design overview, the mission, subsystems, structural analysis, IET, and testing, and also concluding on what we intend to do with our first satellite. So our overall mission is basically to provide temperature and pressure check within by collecting data from space on the continent, and also is to be part of one of the global manufacturing companies in terms of space, small satellite building, and provide the solutions as well. So this is our design overview. So basically, nothing has been reinvented here. We didn't reinvent anything. We just basically follow the way of other people who have done it before. So everything that we're doing currently has been done before. So we're just following the way and modernizing it, and also perhaps re-engineering it. So our design architecture was made to meet the requirement of the Alba deployer, which is a commercial self-component that was drive behind PocketQube building. So as a small satellite company, we build the satellite as well. So, and our subsystem here, we got our OBC board and also got our payload and also got our power. So as you can see in the image here, we got Atmega 3 28P microcontroller, so which is our OBC, like Orbital computer. So in there we have several things that's already there in terms of memory cards and communications, and also have our own payload. So we intend to provide support in communication protocols as well, like 𝗖𝗁 SPI, and also other payload like Earth observatory, satellite communications, providing internet, because that's pretty much very needed on the continent. As you think, in case you don't know, people within African countries pay 3 times to 4 times more for internet than people in the western part of the world. So having small satellites, developed in Ghana and for the continent, will provide and also will give less costly internet connectivity, and also help with weather forecast. A lot of the disasters that occur, many occur due to lack of satellite communications. We have to buy data and we have to pay 3 to 4 times to global data companies for us to be able to get weather forecast for our agriculture, our animal monitoring, even within our habitat development or housing. So having our own small satellite will actually help us, to be able to get control and to get in line with what is happening within the continent. And one of our main goals is also, because as a small satellite company, we also teach young kids, and mostly females, so which is under 15s, under 17s, on how to develop and build satellite. The reason why we chose small satellite because it's cost effective. So with $30,000 to $50,000, you'll be able to build and launch your own satellite. So instead of spending millions of dollars or cracking your head to get millions of dollars to build a big satellite for one country, with just $50,000, you'll be able to build a small satellite, which will also help institutions like schools, high schools, even TAFE or professional schools as well, to be able to build their own satellite for kids or for young people. As the world is evolving, cost is reducing. And we also have our own power. So our small satellite will be working with solar panels and lithium batteries as well, which will help it powered. Because as I said, it's as small as you'll be able to put in your pocket. So that's what we're building for the continent, small but powerful. So depend on the payload, the mission, and what is needed within it. And our communication for receiving, data within our satellite will be the amateur radio. So we'll be using the LoRa long-range transceiver, so which will be on 333 megahertz. So instead of going through bandwidth like KA, KU or X that has high frequency bands, so we're just going to be using long range frequency bands. We can provide a low latency, communication system for us to be able to get data from space that we can be able to transmit or be able to transmit into different applications, like I mentioned earlier, Earth observatory, GPS, and internet or IoT. And our structural analysis, as you can see here, and below board. So it's mostly will be complying, of course, with X Falcon Redshift. So with small satellite, you can have 50 to 100 of them, or even 10 to 20 of them together launched, at once. Because they're very small, you can put them in a rocket and launch them. So they're easy to make, easy to launch, and very cost effective. Because that's mostly what we're here for. We're trying to build systems where everybody will be able to get access to it. And our IET testing, currently we're already done with our flat sat testing, so which is our hardware that we intend to test. So we're already done with that one, and we're currently working on the electromagnetic interference, which is in progress, and also our random vibration is also in progress. So we're trying, to test the electromagnetic of our device, of our hardware, and we intend to launch, our hardware hopefully in December 2026, which is next year. So in conclusion, as we have done one of our first testing, so we are currently working on the EMI and also the other things that are currently in progress. And as I said earlier, we intend to launch in December 2026. So these are some of the applications we intend to provide with our small satellites. So mostly we're going to be focusing on temperature and pressure profiling, also Earth observatory, which is very important for everybody to be able to control a lot of stuff, and also communication. So those are going to be the three main applications that we'll be working towards with our small satellites. And obviously, in the future, we intend to have more of like constellations designed. So where we can have multiple satellites in the air in the low Earth orbit that will provide the solution, and we're collecting data in terms for us to be able to transmit those data into solutions within the continent. So this is the map of our future goals on how we intend. So in the next 5 years, we intend to have as much satellite as we can, perhaps 400 or even 500 small satellites being launched into orbit. So yeah, currently we're working towards one, which should be launched next year, and we intend to have more going on. So we want to be a company who's ready, like products ready in terms of small satellites. So coming from a country like Ghana, we have a lot of issues, problems in terms of technology. So Earth observatory and applications like communications will be really significant for us. So with small satellites, it will be able for us, to be more ready, to be more in line with the global world as well. And this is something that we are introducing as well in the small satellite world. I'm not sure if other companies have also had this kind of ideas, which is laser interrogated corner cube reflector. So having that with a small satellite will be able for us to detect where our small satellites are in the space. So that will also help us minimize space debris, in terms of having more satellites. Because a lot of questions that have been asked, how many satellites in the air, climate change, all that. But with our own laser interrogated corner cube reflector, we'll be able to actually identify where specifically our satellites are based. So where each satellite we launch, we know where they are. So it's more of like a detector. So once one is broken, we'll be able to, extract it to minimize space debris. So in conclusion, like I mentioned earlier, I'm from West Africa, Ghana, and it's a small country with big vision, ambitions, and goal. So one of our goals is to be one of the global leading small satellite company. So with small satellite, we'll be able to provide a lot of solutions. And with solutions, life is easy. So we're working towards reducing cost. As I said earlier, as the world evolves, costs reduce. Thank you for having me.